So this is just going to be the first video introducing orthogonality. Before we go any further, we need to know what it is. So we have vector v, which is in red, and vector u, which is in blue. You see this little kind of square looking thing? It just means that they are perpendicular to each other. So if two vectors are perpendicular to each other, it means that they are orthogonal. Now another way to say this is that their dot product is equal to 0. So let's see, we have vector u is equal to 1, 3, and vector v is equal to 3, negative 1. And we have u dot v, so we take the dot product of these two, if you remember how to do that. Take 1 times 3 plus 3 times negative 1. 1 times 3 is 3, plus negative 3 is 0. So the dot product of these two vectors is 0. That means that they are orthogonal. If we were to draw them out, we have 1, 3, this is u, and this is v, and we can kind of see that they are perpendicular. It's always best to actually do the math to it because your drawings are probably not going to be perfect. Now another way to describe the dot product is u dot v is equal to uv cos theta. And if theta is equal to 90, cos theta is equal to 0. So that is why the dot product of two vectors that are perpendicular has to be 0. Now let's say you're just given one vector. You're given vector u, which is 1, 7. You can draw it out like this. And you are asked to find a vector that is orthogonal to u, meaning you want to find a vector that is perpendicular. You could kind of draw it out, kind of guess, but again, we're going to use math. So if something is orthogonal, it means that the first vector dotted with the second vector has to be 0. We can just rewrite that. So 1x plus 7y is equal to 0. So let's take our y, and we're going to just write it with a t. So y is equal to t. And then x is equal to negative 7 times t, because x is equal to negative 7 times y, which we turn into a t, right? Now let's write this as a matrix. We have vector v is equal to negative 7 times t. Let's continue. So if we know what u is, and we know what v is, well then we're only asked to find a singular vector, right? If we were asked to find an infinite amount of vectors, we could just leave the answer as this, because you could replace t with whatever you want. So for simplicity's sake, we're just going to replace t with 1. So if t is 1, vector v, which I have a little arrow on top of it, is negative 7, 1. If we were to draw it in purple, it looks like this, and we can see that they are perpendicular to each other. Just to make 100% sure that we are right, we're going to dot them together. So u dot v is equal to negative 7 times 1 plus 7 times 1, and that is equal to 0. Now instead of being asked to find one vector, what if we're asked to find all the vectors? Here we're asked to find all the vectors that are orthogonal to u. Now this time, u is in 3 dimensions. So it's 1, 2, 3. Our answer is actually going to be a plane. So plane, it's going to be like a square type thing that is in 3 dimensions, and it's going to be perpendicular to all of these. So to find that, we're going to dot u with v. U dotted with v is 1x plus 2 times y plus 3 times z, and that's equal to 0. Because they asked us to find all the vectors that are orthogonal to u, that is all we're going to do, because we already found the equation for our plane. So you might be asked to find a vector that's orthogonal to another vector using a point. So here we have vector u, which is 1, 2, 3, and we have the point that our other vector passes through, which is 2, 3, 4. We're going to use this equation here. So if we were to rewrite v as just ABC, and we have the point, which is PQR, the equation we're going to use is here. So we are going to just do A multiplied by x minus p plus b multiplied by y minus q plus c multiplied by z minus r. Here we actually have points, right? We have 2, 3, and 4. So if we use this, x minus p is actually x minus 2. Y minus q is y minus 3. Then z minus r is z minus 4. And then we are just going to take the dot product of these two, just like we had on the other slide where we had a multiplied by x minus p. So here we have 1 times x minus 2 plus 2 times x times y minus 3 plus 3 times z minus 4. And all of these have to equal to 0. So again, we have just found all of the possible vectors that there are using these points. And we can just leave it like this, especially for now. In the next video, we're going to go a bit more in depth with orthogonality and start with orthogonal projections.